Hey, in this one I'm going to show you the inproc transport of ZeroMQ, which is basically a way to have your sockets work between threads instead of going over the network, and so consequently it's just a lot, I imagine, faster than going over network, although I've had some strange things on Windows where the TCP is faster somehow, I don't know. But in general I assume it's faster, especially on Linux. So let me just show you how it can be done. So first of all, let's just create a little thread for my publisher. Let's create a thread. This is not a threading tutorial, but yeah, I'm just creating a thread, nothing fancy. Publisher, let's call it routine, the function. Let's pass the context as my argument, like so. Let's create a little threading, little thread routine function, which takes the context. Returns null. Let's create a publisher in there. So nothing new so far. ZeroMQ pub, and we have to. Well, this is the new part. So when we bind the socket, instead of binding to a TCP endpoint, we're gonna bind to an inproc endpoint, which has a very similar structure to the TCP one, except you just replace TCP by inproc, and then you specify an endpoint to it, and this should be unique per socket. So let's just call it my publisher because it's easy. Let's just do a little loop. Let's close the socket because we are clean people. Well, not when it comes to typing, apparently. And let's send something on the publisher, the classical hello message. Like so. Let's sleep a bit so that we don't have an epilepsy attack. And let's do the same thing in the main, and I will copy paste so that it's a bit faster. I think we can do this. Subscriber, like so. So we create a subscriber on the main. Of course, in this case, it's connect, and so you see that the endpoint is the same, and they both use inproc. And here we'll just have a little buffer, like so. No need to sleep. Received. If I can type. This is a buffer, this is the size of the buffer, and we clean the buffer. And this should just work, except that to be even cleaner people, we should join the thread, of course. Publisher thread, null, like so. Let's run this and see what happens. That's not good. What did I do? I think. Oh, well, I'm sending on the subscriber because of my dirty copy paste, and I noticed something else that I forgot to subscribe. So set sock opt subscriber. This will be ZeroMQ subscribe like so, and it will be empty string 0. Let's try that again. And it just works. So we have two threads. The communication is between them. It's done with some kind of hidden mutex in the background to synchronize them, I assume. And it's all, it's faster. You can have as many threads as you want. And so this is where actually a cool thing about ZeroMQ happens. Now that we know that there is a TCP transport and an inproc transport, we can actually bind our publisher to have multiple transport at once, to have multiple endpoints. So, well, I could have like a second inproc transport, but that's completely useless, of course. But what I could do is bind my publisher to something that is between threads and also a TCP endpoint. So let's try that. Like so, 8080. So let's run that. And of course, nothing happens, but I already prepared a little subscriber behind the scenes. So yeah, let's run the little subscriber. And you see it also receives the data. And that was when I saw that you could do that in ZeroMQ, I was like, wow, this is awesome. I mean, of course it makes sense that you can do it, but it's like so nice that I had to add just one line, and all of a sudden like a whole transport thing was handled for me. It's the same message. All the queues in the background are handled for me. And yeah, this is, you can have any kind of transport that you want. So for example, there is an IPC transport, and you could use Unix sockets if you wanted in addition to the other ones. I mean, how can you not be excited about ZeroMQ after seeing this? I don't know. Maybe you don't have a soul if you're not excited about this. Or at least not a programming one. But anyway, that's all I wanted to show, and I'll see you in the next one.